right, so like I said in the first video, we're going to look at vertical transformations of the sine and cosine function today. And I'm going to start by looking at the vertical stretch or compression, which is basically changing the amplitude. All right, so the sine and cosine both have an amplitude of 1, but we can easily change that. So let's take a look at this example to illustrate a change in the amplitude. So in this problem, we have a Ferris wheel that's 36 feet in diameter, mounted to the second floor of a 2-story mall. Okay, and riders board the wheel on the second floor at the dot indicated in the figure, and then the wheel turns counterclockwise, which is convenient, right? We're boarding at theta equals 0, right? and then theta will be measured in the counterclockwise direction. So it says the floors of the mall are 20 feet apart. Write a function for the vertical distance from the second floor in feet as a function of the angle theta as measured counterclockwise from the boarding point on the second floor. Alrighty. So we want to write a function. I'm first of all just going to graph it. All right. So I'm going to draw my little axes here. So this is going to be theta, and this is going to be, I'll call y, the distance from the second floor. Okay, so you can see that when we board here, we are at an angle of 0 because we've defined, or the way we've set this Ferris wheel up so that we're starting at theta equals 0. And then you can see as we move around the Ferris wheel, when we're up here, we're at pi over 2, right? The angle is pi over 2, or 90 degrees. We're up here at the radius of the Ferris wheel. Now it says that the Ferris wheel is 36 feet in diameter, so that means that this radius is 18 feet. Okay, so 18 feet is the radius. Okay, so rather than being at 1, we're at 1 radii of the Ferris wheel, but we're at 18 feet. Okay, so let's say this is pi over 2, and now we're at 18 feet. All right, now let's come around to this point over here. Now we're back down at the second floor, right? So our height above the second floor is 0, and our angle is pi. So here's pi, and we're back down at 0. Now at 3 pi over 2, we're down here. So 270 degrees, we're down here at the bottom, and now we're below the second floor. So we're going to use the sign, let's say sign, then we're going to use the negative to indicate below the second floor, right? So if I extend this a little bit so I can let's say this is negative 18. So we're 18 feet below the second floor. So we can plot that point here. And then finally at 2 pi, we're back at 0. Okay, and then we can just keep going if we want to go around. But one cycle is usually enough. So this is what the graph looks like, right? So just fill this in with the graph of one cycle of this Ferris wheel. Now, what's the equation? We're asked for the equation. This is just a vertical stretch. It's a vertical stretch of the sine function, right? It looks just like the sine function, except our amplitude now is 18. So the function is just going to be a constant multiple of sine. It's just going to be 18 times the sine of theta. Okay, so sine of theta cycles between 1 and negative 1. If we multiply by 18, it's going to cycle between 18 and negative 18. So this multiplier right here is actually the amplitude. Okay, so if we know the amplitude, that's going to be our constant multiple. It's going to be our multiple of the function. And this is a vertical stretch. Okay. All right. Well, I will meet you for the next example.